Now we are going to discuss this particular important plot between B and H, which is essentially called the hysteresis curve. The hysteresis plot is plotted for a ferromagnetic material. The examples of ferromagnetic material is already discussed in the class: iron, cobalt, nickel and gadolinium. Now iron, cobalt and nickel, their ferromagnetism can be attributed to the electrons in the d orbital. However, gadolinium, which is essentially paramagnetic at room temperature, its ferromagnetism can be attributed to those electrons occupying the f orbital. Now, when a ferromagnetic material like iron is subjected to a cycle of magnetization and demagnetization, we get some kind of hysteresis. So what is hysteresis? Hysteresis per se is a very generic term, which means that there is some kind of a lagging. So what kind of lagging occurs in the case of ferromagnetic materials? In the case of ferromagnetic materials, the lagging occurs between H, which is the external magnetic field or the magnetic field strength, and the magnetic induction B. So that is called magnetic hysteresis. Now initially, a ferromagnetic material like iron is subjected to an external magnetic field. When it is subjected to an external magnetic field, you can see from the plot that the magnetic induction increases gradually as well as rapidly. Microscopically speaking, what happens in the sense, there are large amount of domains. We have already discussed what domains are. All these domains, they start aligning in the direction of the external magnetic field. Now there arises a situation where almost 100% of the domains are in alignment with the external magnetic field, and that particular point corresponds to the flattening of the hysteresis curve and is designated as B suffix S, which means magnetic saturation. Beyond B suffix S, beyond this particular point, any material, any ferromagnetic material for that matter, cannot be magnetized any further. Now we will see what happens when the external magnetic field is decreased. So here the external magnetic field is gradually decreased and is made zero. When it is made zero, you can observe from the plot that the magnetic induction does not disappear. So the ferromagnetic material, it retains some amount of magnetism within itself. In other words, it has got some kind of magnetic retentivity designated by the term B suffix R. It has got some kind of remnant magnetization, and in other words, we can also call this as magnetic memory. In fact, this is being exploited for memory related applications. Now what we do is we reverse the field direction. So from this plot you can see that instead of imposing a magnetic field along the positive x-axis, a magnetic field is imposed along the negative x-axis. When the magnetic field is imposed along the negative x-axis, the magnetic induction gradually falls and disappears altogether at a particular point Hc, which corresponds to the coercive field. So coercive field is nothing but the field required to completely demagnetize a material. Now once again, this does not hold good for a long period of time. If the magnetic field is increased in the external magnetic field is increased in the same direction, that is negative direction, the magnetic induction also picks up. Once again it attains the saturation limit. Now we tend to decrease the magnetic field, and when the magnetic field is brought to zero, there is this magnetic memory or the remnant magnetization witnessed. Now the field is subjected or applied along the positive x-axis. The magnetic induction decreases and disappears at plus Hc. Once again, when the magnetic field is increased, the magnetic induction also increases. So this cycle of magnetization and demagnetization takes place in iron. You can see that B does not follow H. So there is always a lagging between B and H. This lagging is termed as magnetic hysteresis. Why this happens? The reason why this happens is because of the large number of domains not being able to follow the field reversal of the external magnetic field H. So these are the important points in the hysteresis curve.